Hi there. Here's my solution to 6.89. So we're looking at the same data as question 6.87, same table. So this time, part A, what is the probability that a randomly chosen degree recipient is a man? So part A, the probability of a male. In this case, we need to go look at the male total and compare it to the table total. So we'll come up here. The male total was 825. The table total was 1944. So there is our ratio. The 825 compared to the 1944. We are done with part B, or rather part A. For part B, what is the conditional probability that the person chosen received a bachelor's degree? So for part B, I want the probability that we have a bachelor's degree. So given that he is a man, so under the condition that we are only looking at the males. So the males are identified by a row, so we're going to isolate ourselves to simply the male row. So within the male row, there it is, 559 have bachelor's degrees out of a total in that row of 825. 559 out of 825 if we isolate ourselves just to that particular row. So last then, in part C, you're asked to use the multiplication rule to find the joint probability of choosing a male bachelor's degree recipient. Check your result by finding this probability directly from the table of counts. So first of all, let's make sure you know what we mean by the multiplication rule. So the multiplication rule says that the probability of having a bachelor's degree and being male. So that should be the probability of being male times the probability of having a bachelor's degree. But under a condition. We don't know that these are independent events, so the probability of having a bachelor's degree but already knowing that I have chosen a male. So now understand, we've already calculated these values, so this right here is the joint probability, having a bachelor's degree and being a male. So here, the probability of a male, I've got from part A, that's 825 over 1944. The probability then of having the bachelor's degree, given that I'm only looking at the males, I calculated that in part B. That is 559 divided by 825. Now notice what just happened. Do you see how the 825s cancel? So that gives us in total 559 out of 1,944. That 559 then represents the number of people that are both male and have bachelor's degrees out of the table total of 1944. So we just used the answers from parts A and B in order to calculate this answer to part C. We're going to check, though, to make sure that that result makes sense, because we could have gotten the same answer without using the multiplication rule. We could just get that answer. We could grab it out of the table of counts. So go look. In the table of counts, if you look at the intersection of males and bachelor's degrees, here is the male row, here is the bachelor degree column. So males with bachelor's degrees, that is 559. That is the count out of a table total of 1944. That is exactly what we found using the multiplication rule, the general multiplication rule in part C.